Thank you very much, and good morning to everybody. It's great to be back here in Obregon. I actually worked for CIMMYT for many years, and the last time I was here was 20 years ago, so it's a great return. Roger, on the first day of this conference mentioned the tensions between Norman Borlaug and environmentalists. And I actually witnessed that very vividly, I think, in my first visit to Obregon in 1977 on a field visit that we had like on Tuesday, and a young man in the audience asked a question about the impacts of pesticides on birds. That led to a very strong response from Norm, indicating the importance of feeding the world, and we need all our tools to do that. And I don't think that young man asked another question for the rest of the week. But the point, the irony of all of that is that another very important legacy of Norman Borlaug is in the environmental literature, relating to the changes, the impact of increasing yields on land use and deforestation. And remember that he had a background in forestry and was particularly interested in that relationship. So perhaps many of you are not aware of that legacy, but it's very strong in the environmental literature. So it all comes from these relationships that over the last 50 years, we have increased the per capita crop production by about 40%. We've done that with about half of the land per capita that we had in 1961. And up until 2006, we did it while we were reducing real prices by about 40%. Truly a remarkable accomplishment. And all of that is due to the figure that you've seen on the right-hand side a number of times during this conference of the increases in crop yield over that period. And Borlaug particularly emphasized this relationship between land saving and increases in yield, and an article in Science put a figure on this of about 1 billion hectares. And this saving of land from increasing yields is very much enshrined in the literature now, particularly environmental literature. If you go to Wikipedia, the fount of all knowledge, there's an entry under the Borlaug Hypothesis, so-called Borlaug Hypothesis, about this relationship. You notice at the bottom that the editor in Wikipedia is calling for a bit more verification and citation. I thought I would help on that to say where is the origin of this term, the Borlaug Hypothesis, on the relationship between intensification and land use. I traced it back to an article book by two economists, Angelson and Kamowitz, both forest economists, in 2001, talking about, and actually in that book, referring to this relationship as the Borlaug Hypothesis, and also referring to a speech made by the chair of the CGIAR that if you want to save the rainforest in the Congo, you have to invest in R&D to increase agricultural productivity. But Angelson and Kamowitz were very good economists, and they said, well, the world is not that simple. It's more complicated. And so they offered another view, which is that increasing yields on the forest frontier actually raises the productivity of agriculture, raises the returns to land, and therefore gives you incentives to expand your land area. And so this is what Byerlee talked about in relation to water, so-called Jevons paradox. The more productive an input, the more you use of it. And this leads to, and evidence of this is seen, perhaps if you look at the sources of growth over these same 50 years and you start decomposing by regions, you see at least 3 regions, increases in land, cropland area have been an important source of growth. even though some of those regions of Southeast Asia, Brazil, and Sub-Saharan Africa, and at least two of those regions, and particularly Brazil, that increase in land use has been accomplished by significant technical change as well. That's the green area on this graph. So this leads to somewhat conflicting views about what we do in terms of investing in R&D, in terms of saving land and forests. And you take the proceedings of the National Academy of Science, for example, in 2010, an article by Byerlee and colleagues, and they looked at they concluded that increased global yields since 1961 have actually saved 1.5 billion hectares of land, even larger estimate than Norman Borlaug had estimated. And they actually related this to investment in R&D, and that 1/3 of that saved land was due to the cumulative investment over that period of some $800 billion in agricultural R&D. 3 years later, we have an article from Phelps and colleagues in the same journal looking at the effects of improved maize and cassava technologies on forest in the Democratic Republic of the Congo. And their conclusion is that the relationship between intensification and land sparing for conservation in tropical developing countries is dubious. Intensification may actually spur agricultural expansion. So if you listen to that conclusion, you have real questions about investing in R&D. And this is a country that was actually showed on the Global Hunger Index as one of the most severe countries in terms of the incidence of hunger. Okay, so I want to talk about those conflicting views of the world. I'm going to start a little bit with where we are on land scarcity. We're using about 1.5 billion hectares of land for crops out of only about 12% of the surface area. Of that 1.5 billion hectares, we have converted over 1 billion hectares since 1850 from natural vegetation to cropland. But over the last 20 years or so, probably 30 years, that conversion has slowed down very drastically, and we've only increased cropland use by about 2%. Right now, there's a very active discussions on this new sustainable development goals to push for a target of zero deforestation by 2030, which would have significant implications for even slower growth in agricultural cropland. However, that global picture is different when we start looking at the tropical belt of countries. If you look at the FAO data, for example, there's been about 100 million hectares expansion of crop area in the tropical countries, largely Latin America, Southeast Asia, and Sub-Saharan Africa since 1990. Much of it has been on both food crops, animal feed crops, as well as some of the perennial crops like oil palm and sugarcane. Also, there's a lot of literature coming out using satellite imagery to track changes in land use, and a very highly cited article by Gibbs shows that there's been a period 1980 to 2000, there was a 75 million hectare conversion of land into agriculture in the tropical countries, and 75% of that came from forests. So there is in this region, the tropical belt of countries, there does appear to be very strong evidence of a significant conversion of forest land to agriculture. Looking at the demand for land for the future, lots of estimates out there, including some that I've been involved in, but I'm going to use this slide again from PNAS Journal, from Eric Lambin, colleague at Stanford University, looking at a low estimate, high estimate, additional land for crops Biofuels, we're already using about 50 million hectares of land for biofuels. It could go up to over 100 million hectares. Forestry, grazing, and so on. But also adding to that, recognizing that we're losing land. And we're losing land to cities and infrastructure, particularly in the densely populated areas of Asia. We're losing land to degradation, very, very poor estimates of this actually, as well as conversion to protected areas. So if we add all of that up, then the gross land needs by these, sort of a meta-analysis of the various estimates out there, would range from about 200 million hectares in additional hectares in 2030 to 450 million hectares in 2030. Is that land available? Another exercise I've been involved in is looking at the potential to expand crop area based on land that's moderately or better suited for crop production. In addition, the FAO comes up with a figure of 1.4 billion hectares for this. But when we strip away the area that's already forested, the area that's protected, and just look at the lower population density areas, we come up with a figure of 450 million hectares, out of which about 75 million hectares, by the way, is suitable for wheat production, mostly in Russia or Ukraine. That land is very highly concentrated in a very few countries. Nearly half of it in Africa, in a few countries in Africa, South America, Brazil and Argentina, and Russia. Since this estimate came out, there have been a number of other estimates suggesting that we were too high in our estimates. So you put that together with the figures I gave you for land demand to 2030, indicates that we are in a period of approaching significant land scarcity and closing the land frontier. There's also a perception of land scarcity out there, and together with high commodity prices, that perception has led to a surge in large-scale investments in farmland that Per mentioned a couple of days ago. There are many estimates out there. Generally, the media and the popular press has significantly overestimated these investments, but they are a very important phenomenon. So a couple of sources on this. The wiki estimates, so crowdsourcing estimates in the land matrix database, some 1,000 projects of more than 2,000 hectares with 35 million hectares taken for these investments. And you can see the countries, pretty much the same set of countries where the land was available that I had on a previous slide. Another estimate, I think, is very carefully done for Africa by Schoenveld and colleagues, the 18 million hectares in recent years, a significant amount of that for biofuels. Obviously, this type of investment has been quite controversial, and it's often with significant social and environmental risk. I'll focus just on the environmental side here. One of the big expansions, you notice Indonesia was the #1 country in terms of these investments. And a lot of that is oil palm. It's doubled every year. Area has doubled every year, every decade since 1970. I estimate there's been about a $50 billion investment in oil palm just in the last 10 years or so. And a lot of that has very significant environmental costs, as you see on the right-hand side, moving from the green to the deforested area, the brown and the orange, in Riau province, which is the #1 oil palm producing province of Indonesia. Okay, so let's move on and talk about this, get back to this issue of intensification. Will it save these forests? I'm going to talk about some of the modeling work that's been done because I think that gives us the best insights at this moment. There's a lot of statistical work, but I think often of dubious value. And recognizing the modeling work tries to put together some of these various pathways from intensification to land use. So the first pathway I've already mentioned, intensification on the frontier leading to higher returns to land and then pressure to expand land area. You can have intensification through labor, particularly intensification away from the frontier, drawing labor from the frontier, reducing pressure. There's considerable evidence that this happened with the Green Revolution. And then broad-based intensification that at a more of a regional, global level, impacts through trade on reduced output prices, decreased returns to land, and reduced pressure on land area. I'm going to talk about just 3 results of 3 different modeling efforts here. The first one is the Gtype model, a global general equilibrium model that's been combined with spatially explicit databases on yield and land use. And this is work that I was involved in with James Stevenson and colleagues, where we took the counterfactual of a world without CGIAR germplasm. And the idea is that within these types of models, particularly on the land use, we could model the trade-offs in land use from crops to pastures to forest. And let me say that modeling work at the moment is very much in its infancy. There's often some very crude estimates of many of the parameters. We came up with a figure on doing that through the period 1965 to 2007, that without the CGIAR germplasm work, the area under crops, food crops, would have increased by 18 to 27 million hectares, most of that in developing countries. Now, notice that this is an order of difference of the billions of hectares of some of the previous estimates we've talked about, but it is still a very significant contribution to land saving, although let's keep it in perspective that this impact is dwarfed by the effects of lower food prices from the CGIAR germplasm work on human welfare. So let's keep this in perspective. A second activity is really looking and using the same set of models, looking at intensification on the frontier only, looking at closing the yield gap in oil palm in Southeast Asia for a 25-year period. And we did find here on the left that in that case, the Jevons paradox seems to hold in a small way, in that you increase crop area and reduce forest in Southeast Asia because you make oil palm more profitable. But when you track that through trade and the impacts on prices through trade, in fact, you get increases in forest area, reductions in crop area in many other regions of the world, and a significant net savings in crop area. Now, you have to then trade off the value of this forest here that's lost with the forest area that is gained in other regions. And then another, I think, very good analysis by another colleague at Stanford University, David Lobel, looking at the investment in R&D to adapt to climate change and then the impact that would have on land use. So they looked at 3 scenarios: no adaptation, investment in R&D to perfectly adapt to climate change so that yields would be not affected by climate change, and then adaptation just in Latin America and Africa, in more focused on the tropical zone. So they concluded that investing in R&D for broad adaptation to climate change is a cost-effective way to save forests and mitigate climate change. So I think this is quite an interesting finding, that if we can invest to adapt to climate change, we can also have a big impact on saving forests and mitigating climate change. But I think one other sobering result of that very careful exercise, and I think this is one where they've done a lot of sensitivity analysis and actually given us some confidence intervals on their estimates, is they still project about 250 million hectares of land will be required, additional land will be required by 2030, even under perfect adaptation. So that somewhat indicates that we still haven't reached the land frontier. I think there's been a lot of confusion out there, particularly in environmental literature, about intensification and deforestation, and the confusion has been technological-induced intensification, which is what I've been talking about, and market-induced intensification. And a lot of the intensification is due to opening up of new markets, and particularly with global trade that we've seen over the last couple of decades. And just a couple of commodities that I'm working on, spending all my time on this year, on oil palm and soybeans. These are the really dynamic commodities now in international trade and international markets. In fact, wheat has been the #1 traded commodity for over 150 years. Now soybeans is significantly more important than wheat in international trade. And last year, palm oil became more important than wheat in international trade. So some very major shifts in the global mix in international trade. So this market-induced intensification is probably much more important, particularly in the tropical areas, in changing land use. Although in the case of soybeans, we have to say also there's been some very significant technological change. In oil palm, there really hasn't been technological change. The basic technology that's used in oil palm production is from the 1960s. Just a very quick slide that I don't think I need to dwell on, but obviously it's not, intensification comes in many forms. The type of intensification matters, and obviously we want sustainable intensification through higher input efficiency, improved natural resource management. I think there's a very good review of that in a chapter in the Tony Fisher volume that was discussed yesterday. And then also there's quite a bit of debate about intensification, the land-sparing approaches where you specialize versus the land-sharing approaches where you look at think about more biodiverse mosaics. So to finish up then, what's the bottom line on all of this? The conclusion, I think the first conclusion, that broad-based investment in crop R&D is one of the best ways to save forests globally. And this, of course, goes back to say Norman Borlaug was right once again, even in the environmental literature. But there's some buts on that. The net global saving in land from intensification often coexists with forest losses at the local level. And I think this has been forgotten. We look at these global savings, but often when you get down to the local level, you can have saving at the global level, but losses at the local level. The improved governance of forests is critical to provide incentives to intensify, and I think this message has not been clearly put through, in that if you're in a situation where it's much easier to expand your land area at the forest margin than to intensify, then you're going to go for the easiest option, and that is to expand. So you need regulations, incentives, and many of the private certification systems, for example, that are coming up. And I think there's a good example here, Brazil versus Indonesia. Brazil has been quite successful in slowing down deforestation, very successful over the last 10 years or so. Indonesia has been much less successful, so much less incentive to intensify in Indonesia. And finally, if we're going to have a sustainable development goal of zero deforestation in 2030, we're going to have a combination of accelerated efforts in expanding yields as well as accelerated efforts to improve governance of forest and land resources. Thank you very much, and I'd like to acknowledge colleagues that have been involved in this work particularly James Stevenson of the Science Council and Nelson Villoria at Purdue University.